Welcome to Maths Guide at Home. Our channel provides easy to follow math tutorials and explanations to help you improve your skills and understanding. Be sure to watch each video in full to not miss any important information. Let's dive in. In this session, we will be learning about rationalizing the denominator. As a quick introduction, this process involves removing radicals or square roots from the denominator of a fraction to simplify the expression. We will explore the steps involved and provide examples to help you understand the concept. Let's get started. Before we start dealing with complex numbers, let's clear the concept of conjugate numbers. The conjugate of a complex number is another related complex number that has the same real part as the original number, but the imaginary part has the opposite sign. Let's consider the complex number 2 plus 3i. In the expression 2 plus 3i, 2 is a real number, and 3i is an imaginary number because it contains the imaginary unit I. To find the conjugate of this complex number, we simply flip the sign of the imaginary part, plus 3i, to get minus 3i. Therefore, the conjugate of 2 plus 3i is 2 minus 3i. Note that the real part, 2, stays the same, while the imaginary part changes sign from plus 3i to minus 3i. Similarly, the conjugate of 3 plus 2i is 3 minus 2i. We can find the conjugate of any complex number by changing the sign of its imaginary part. Here are a few more examples to help you understand the concept of conjugate numbers. 1. The conjugate of 2 minus 5i is 2 plus 5i, since we just need to flip the sign of the imaginary part. 2. The conjugate of 6 is 6, since real numbers have no imaginary part. 3. The conjugate of minus 4i is 4i, since we just need to flip the sign of the imaginary part. 4. The conjugate of 1 plus i is 1 minus I, since we just need to flip the sign of the imaginary part. 5. The conjugate of 7 minus 3i is 7 plus 3i, since we just need to flip the sign of the imaginary part. 6. The conjugate of 0.5 minus 2.3i is 0.5 plus 2.3i, since we just need to flip the sign of the imaginary part. 7. The conjugate of minus 9 is minus 9, since real numbers have no imaginary part. 8. The conjugate of the square root of 2 plus 3i is square root of 2 minus 3i, since we just need to flip the sign of the imaginary part. 9. The conjugate of 7 minus 8i is minus 7 plus 8i, since we just need to flip the sign of the imaginary part. Remember, when finding the conjugate of a complex number, we change the sign of its imaginary part to get its conjugate. Example number 1. When we have a square root in the denominator of a fraction, we say that the fraction has a radical or irrational denominator. Our goal is to rewrite the fraction so that a denominator is a rational number, which is a number that can be expressed as a simple fraction or decimal. To eliminate the radical in the denominator, we can multiply both the numerator and denominator of the fraction by the same expression that will cancel out the radical. Please note root 5 into root 5 is equal to 5. In the case of 2 by root 5, we want to eliminate the square root of 5 in the denominator. So, we will multiply both the numerator and denominator by root 5. Now, 2 by root 5 when multiplied both numerator and denominator by root 5, we get 2 root 5 by 5. Please note root 5 into root 5 cancel each other and we have left 5 with us. Therefore, the rationalized form of 2 by root 5 is 2 root 5 by 5, which is a simplified expression with a rational denominator. Example number 2. To rationalize the denominator of the fraction 1 by 5 plus 4 root 5, we need to eliminate the square root in the denominator. To do this, we will multiply both the numerator and denominator of the fraction by the conjugate of the denominator, which is 5 minus 4 root 5. Now, we multiply both numerator and denominator 1 upon 5 plus 4 root 5 by 5 minus 4 root 5. We multiply 1 and 5 minus 4 root 5, we get 5 minus 4 root 5. Now, coming to the denominator, when we examine carefully we observed that this one is in the form of a plus b and this one in the form of a minus b. Whenever we get any such expression, we use the formula a square minus b square is equal to a plus b and a minus b. Applying the same formula here, we get 5 square minus 4 root 5 whole square. Next step, we get the numerator as it is 5 minus 4 root 5 divide whole by 25 minus and 16 into 5 is equal to minus 80. Finally, we get 5 minus 4 root 5 by minus 55. Therefore, the simplification of 1 by 5 plus 4 root 5 is 5 minus 4 root 5 by minus 55. To rationalize the denominator of the fraction root 3 plus root 5 upon root 3 minus root 5, we need to eliminate the square root in the denominator. One way to do this is by multiplying both the numerator and denominator of the fraction by the conjugate of the denominator, which is the same as the denominator but with the opposite sign between the terms. In this case, the conjugate of the denominator, root 3 minus root 5 is root 3 plus root 5. So, we can multiply both the numerator and denominator of the fraction by root 3 plus root 5. Let us multiply root 3 and root 3 plus root 5 and plus root 5 and root 3 plus root 5. Divide whole by. Here, root 3 minus root 5 and root 3 plus root 5. Looking at it carefully, we have found the expression in the form of a square minus b square. So here we have root 3 whole square minus root 5 whole square. Next step. Let's open up the bracket. We have root into root 3. As 3, please note that root 3 into root 3 here. Root cancels as each other and we get 3. And root 3 into root 5, we get root 15. And again, plus root 5 into root 3 we get root 15 and plus root 5 into root 5, we get 5. Please note that root 5 into root 5 here. Root cancels as each other and we get 5. Now, we have 3 plus root 15 plus root 15. We get to root 15 and plus 5. Divide whole by 3 minus 5 as minus 2. Now dot 3 plus 5 is equal to 8 and to root divide whole by minus 2. Let us segregate 8 by minus 2. We get minus 4 and to root 15 divide by minus root 2. We get minus root 15. Bring up the minus sign, we have minus 4 plus root 15. Therefore, the simplified expression of root 3 plus root 5 upon root 3 minus root 5 is equal to minus 4 plus root 15. To rationalize the denominator of the fraction 3 plus root 7 upon 3 minus to root 7, we need to eliminate the square root in the denominator. One way to do this is by multiplying both the numerator and denominator of the fraction by the conjugate of the denominator, which is the same as the denominator but with the opposite sign between the terms. In this case, the conjugate of the denominator 3 minus to root 7 is 3 plus to root 7. So, we can multiply both the numerator and denominator of the fraction by 3 plus to root 7. Let us multiply 3 and 3 plus to root 7 and plus to root 7 and 3 plus to root 7. Divide whole by 3 minus to root 7 and 3 plus to root 7. Looking at it carefully, we have found the expression in the form of a square minus b square. So here we have 3 whole square minus 2 root 7 whole square. Next step. Let's open up the bracket. We have 3 into 3 as 9 and 3 into 2 root 7, we get 6 root 7. And again, plus 2 root 7 into 3 we get 6 root 7 and plus 2 root 7 into 2 root 7, we get 4 into 7 as 28. Please note that root 7 into root 7 here, root cancels as each other, and we get 7. Now, we have 9 plus 28 is equal to 37 and here and 6 root 7 plus 6 root 7 is equal to 12 root 7 here. Divide whole by 9 minus 28 as minus 19. Bring up the minus sign, we have minus 37 minus 12 root 7 divide whole by 19. Therefore, the simplified expression of 3 plus to root 7 upon 3 minus to root 7 is equal to minus 37 minus 12 root 7 divide whole by 19. To rationalize the denominator of the fraction 4 plus root 5 by 3 minus to root 5, we need to eliminate the square root in the denominator. To do this, we will multiply both the numerator and denominator of the fraction by the conjugate of the denominator, which is 3 plus to root 5. Please note that of conjugate of 3 minus to root 5 is 3 plus 2 root 5. Let us multiply 4 and 3 plus to root 5 and minus root 5 and 3 plus to root 5. Divide whole by 3 minus to root 5 and 3 plus to root 5. Looking at it carefully, we have found the expression in the form of a square minus b square. So here we have 3 whole square minus 2 root 5 whole square. Next step. Let's open up the bracket. We have 4 into 3 as 12 and 4 into 2 root 5, we get 8 root 5. And again minus root 5 into 3 we get minus 3 root 5 and minus root 5 into 2 root 5, we get minus 2 into 5 as 10. Please note that root 5 into root 5 here, root cancels as each other, and we get 5. We get 12 plus 8 root 5 minus 3 root 5 and minus 10. Divide whole by 9 minus 10, we get minus 1. Now, bring the minus sign in the numerator, we get minus and everything inside the bracket. Therefore, 4 plus root 5 by 3 minus 2 roots 5 is equal to minus 2 plus 5 root 5. To rationalize the denominator of the fraction 8 minus 2 root 6 by 2 root 3 plus 3 root 2, we need to eliminate the square root in the denominator. To do this, we will multiply both the numerator and denominator of the fraction by the conjugate of the denominator, which is 2 root 3 minus 3 root 2. Please note that of conjugate to root 3 plus 3 root 2 is 2 root 3 minus 3 root 2. Let us multiply 8 and 2 root 3 minus 3 root 2. This time multiply minus 2 root 6 and 2 root 3 minus 3 root 2. Divided whole by. Here, 2 root 3 plus 3 root 2 and 2 root 3 minus root 2 is in the form of a square minus b square. So here we have 2 root 3 whole square minus 3 root 2 whole square. Next step. Let's open up the bracket. We have 8 into 2 root 3. We have 16 root 3 again. 8 into minus 3 root 2. We have 24 root 2. This time multiply with minus 2 root 6 into 2 root 3. We have minus 4 root 18 and again minus 2 root 6 into minus 3 root 2. We have plus 6 root 12. In denominator, we have 4 into 3 is 12 minus 9 into 2 is 18. Now, here, this one as it is, this also as it is, here, we have minus 4 into 3 root 2 and root 2 plus 6 into 2 root 3. You must have noticed that the change in expression of root 18 and root 12 into root 2 and root 3 form. To understand this, root 18, we know root 18 as root 9 into root 2. Now, 3 into 3 equals to 9, hence 3 square. Here square and root cancel each other, and we have 3 and root 2. Similarly, root 12, we know root 12 as root 4 into root 3. Now, 2 into 2 equals to 4, hence 2 square. Here square and root cancel each other, and we have 2 and root 3 left with us. Now, add or subtract the like roots accordingly. We have 28 root 3 minus 36 root 2. After simplifying, we have here minus 14 upon 3 into root 3 plus 6 root 2. Therefore, 8 minus 2 root 6 by 2 root 3 plus 3 root 2 is minus 14 upon 3 into root 3 plus 6 root 2. With this, we conclude today's session. We hope that the explanations provided were helpful and improved your understanding of the math concepts covered. If you have any further queries or math-related issues, please leave a comment below, and we will do our best to address them in future videos. Don't forget to like and subscribe to our channel for more informative math tutorials. Thank you for watching, and we look forward to seeing you in the next session.